Hello, Charan. Good evening. How are you?
Fine, sir.
All right. Okay, let's just wait for a minute. What happened? Any other class going on or what?
Before it was other class was there, sir. For me.
Yep. Okay, Lokesh there. Okay, then let's just start now. So in the mechanics part, we were discussing NLM, right? So we discussed about the different, all three laws of motion we discussed. Then we discussed about the different type of forces like gravitation force, okay, normal force, spring force we discussed, right? Combination of spring, equilibrium condition we discussed, isn't it? And accelerated motion we discussed was the last thing we discussed in this chapter. Okay. Let's continue now. Okay. So these are the forces we have discussed, isn't it? Normal, tension, spring force. Okay. All these type of forces we have discussed in our class. Okay. Now, next we have to discuss is what is called the friction force. Okay, friction force we have not yet discussed. And one more is there called the pulley constraint. Okay, pulley constraint means what? It's a simple application of the uh, Newton's law of motion. Okay, so let's discuss one topic. This is extra topic. Okay, as per your uh, AP mechanics syllabus, it is not there that mentioned. But if a question comes, how you will solve it? So that's why I'm going to just to discuss a small part of the pulley constraint. Okay. So pulley constraint means what? You have seen if a string is connecting two blocks, then what will happen? Both the block are going to have what? The same acceleration, isn't it? But sometime what will happen? They are not connected in the straightforward manner. Meaning is what? That they are connected. One string is connecting the other block, two block, and other string is connecting some other block. Like that kind of situation is given to us. That is called what? The pulley constraint. Okay. So this is just one extra topic. It won't take much time. Let's discuss it. Okay, now that is called the pulley constraint, or also called as the constraint relation. So in the constraint relation, what we do here, more than two blocks are connected with the help of not a single string. A different arrangement of a string is given to us. Like let's take an example here and try to understand the pulley constraint. Okay. In this example, what happened? This is how the pulley is given to us. Okay, something like this. Okay, and here let me just make it one more. Okay, this is how it is connected, and there is one block connected here. Okay, and these two pulley are connecting the other block. You see, this is the M1 block and this is the M2 block. Now if you see these two block, they are connected with the help of a string only, but are they connected with the help of same string? Look at M1 and M2. Are they going to have the same acceleration? So in this question, this M1 and M2 are not going to have the same acceleration. The question gave what? Let's say acceleration of M1 is given A1 and acceleration of M2 is given as A2. The question is asking what? Find relation between, okay, relation between what? A1 and A2. Understand the question? What they are asking the question? Find the relation between what? A1 and A2. This is what they are asking in the question. So how do we find out that one? So pulley constraint says what? Whenever we have to apply the pulley constraint, first of all, we should identify what is the tension acting on each block. Now look at that. This string is same now. See that. This string is same, that black color string. So everywhere in this string is going to have what? The same tension, right? So if you look at the block M2, just look at the tension only, okay? What is the tension in the block M2? Let's say it is T. Look at this tension is T. So can I say here the tension will be T? Here also throughout the string the tension will be T. Here also throughout the string the tension will be T. So can you tell me what is the tension in this blue string? Is that going to be 2T? Why? Because it is a ideal pulley, it is a massless pulley, isn't it? So if on the pulley, right, upward side tension is T and T acting, so downward side also tension, how much should be acting? Same. That's why 2T. Look at this green one. Green one. Again, here the tension is T, here the tension is T. So in the green string, what will be the tension acting? 2T will be acting. So if you look at the M1 block, you will find out how much tension is acting on the green block. It is acting 2T and another 2T, 4T. Please tell me first, do you understand the value of tension in both the block? Please tell me. If a block or any pulley is given to us, then both sides of the pulley will have what? The same tension. Now write the acceleration. What is the M2 acceleration? M2 acceleration is A2. M1 acceleration, how much is there? A1. Okay. So as per pulley constraint, what we will get it? What is the pulley constraint says? As per pulley constraint, summation T dot A should be equal to 0. What is T and what is A? T is the tension acting on the block. A is the acceleration of the block. And dot means what? We are taking the dot product of tension and the acceleration. Okay. So look at the M1 block. Now tell me, what is the tension acting on M1 block? 4T, isn't it? What is the tension acting on M1 block? 4T. What is the acceleration of M1 block? A1. What is the angle between tension and acceleration? See that tension is upward direction, acceleration downward direction. So what is the angle between them? Cos 180 degree. Plus summation means adding all of them. Na? Here two blocks are there, so two term we will add it. If three blocks are there, so three term we will add it. Understood? Now M2 block, tell me, tension is T, acceleration is A2, angle between them 0 degree. That summation should be equal to 0. Now simplify it. Now if you simplify it, T get cancel out. You know? And what is the A2 coming? A2 is coming 4A1 to us. So that is the relation between what? A1 and A2. Understood? This is the relation between the acceleration of the block 1 and block 2. Understood? So this is how we apply the pulley constraint. Will you try one question by yourself? Please tell me. Can I give you one question and try to solve it one question by yourself? Please tell.
Yes, sir.
All of you, please tell me. Charan, Lokesh, Sushant.
Yes, sir.
Yes, sir.
Okay. Let me give a question. You try. If you understand how to write the tension in these cases, na, you will be very easily able to apply the pulley constraint. Okay. Let's say an example I'm giving to you. This is the M1 block connected over the pulley like this. This is a fixed pulley. And lower side, we have another pulley. Understood? We have one more pulley. And this is another string. And this string is connecting what? The two different block. Let's call it M2 and M3. Okay. You want to represent it with a different color, represent it like this. This is a single string, black color string. This is a single string, the blue color string. Okay. I am giving the acceleration of these block so that you can write the relation A1. This one I am giving A2. This one I am giving A3. Understand? M1 block A1 acceleration, M2 block A2 acceleration downward, M3 block A3 acceleration upward given. Okay. Now again they are asking in the question, find relation between find relation between A1, A2 and A3. Okay. Please try it now this question. Just you try to apply it by yourself. Take 2 minute time and just try to solve this question by yourself. See that what we are getting the relation between A1, A2 and A3. Please check it. How much is that coming? First of all, what you have to do? First of all, you have to find the tension in each string which is connecting the blocks. So first of all, find the tension in these strings. Okay, first of all, find the tension in these string. Assume something T that will always get cancelled out. Whenever you will write the pulley constraint, na, T will always get cancelled out. So don't worry about it where you are considering the tension T. But you have to write the tension properly with the help of that one. Okay. So please tell me which string you want to take tension T, blue string or black one?
Blue.
Blue. Let's take the tension here T. So here tension T, here tension T. So can you tell me black string will have what tension? Sometime it will be shown like this. The black string will have what tension? 2T will be there. Understood? Black string, what will happen? Because it's a ideal pulley, na? The both side of an ideal pulley will have what? The same amount of tension force, isn't it? So downward side it is T and T, 2T. So upward side also it should be how much? 2T. Now look at the blocks. M1 block. What is the tension? 2T, है ना? M1 block is connected with black string. Na? Black string has what tension? Throughout. 2T. What is the acceleration? A1. M2 block. What is the tension? T upward. What is the acceleration? A2 downward. And M3 block, you see that? T tension upward. A3 acceleration also upward. Now we will write the summation of T dot A equal to 0. Tell me for the block M1. What is the equation you will write it? Tension is 2T, acceleration is A1, angle between them is what? 0 degree plus. M2 block, what is the tension? T, acceleration A2, angle between them 180 degree plus. Third block, tension T, acceleration A3, angle between them 0 degree. That three summation should be equal to 0. You see that in the simplification process, T and T got cancel out. So what we have? 2A1, because cos 0 is 1 and cos 180 is minus 1. Okay, so A2 to minus A2 and A3, that should be equal to 0. So what is the relation we are getting here? 2A1 equal to A2 minus A3 we have, or you can also write it A1 equal to A2 minus A3 by 2. Clear? So that is the relation between the tension of, sorry, relation between the acceleration of these three blocks. So this is called what? The pulley constraint. Pulley constraint, when do we apply? Whenever the blocks are not having same acceleration. And when these blocks will not have same acceleration? When they are connected through different string. When these blocks are connected through different string, then what will happen? Then these blocks will not have the same acceleration. In those cases, what we should do? We should write their acceleration as different, and then with the help of pulley constraint, we should relate those acceleration. Clear this one? Please tell me.
Yes, sir.
So this is called the pulley constraint. Now, the next type of force we have not yet discussed is the friction force. The friction force itself is a complete topic. Okay, so let's discuss about the friction force now, because now in some of the questions we have to see what is the friction force acting, how much is that acting, what is the direction of friction force, what type of friction force is there. Okay, so let's discuss about the friction force now. Okay, so till now we have calculated what kind of forces? Tension, normal, spring, gravitational force, right? Gravitation force, we have to discuss it much more detail. Don't worry about it. Newton's law of gravitation, gravitational field, these things we will discuss in more detail. But right now, let's focus on the friction force. Okay. So what is a friction force? Tell me. Friction force means what? Whenever two rough object, friction force when it will be acting, whenever two rough objects or whenever the two rough surfaces are in contact with each other, na, then what will happen? They will apply friction force on each other. And how they will apply the friction force? Along the surface in contact. Means if your two palms are in contact with each other, how the friction force is acting on both the palm? Along the surface. Understood? So what is a friction force? It is the force, it is the force acting between what? Between two rough surfaces. Okay, between what? Between two rough surfaces being in contact. Okay, both the rough surface is what? Being in contact. Then what will happen? They will apply the friction force between them. And which direction it will be acting? It will act along the surface, right? It will act what? Along the surface. Is that clear? See, all these type of forces we have now, they have fixed directions, like normal always perpendicular to the surface and pushing the object away. Tension always along the string pulling the object. Okay, na? So all these forces have what? A fixed type of direction. So what direction it will be acting? It will always act. It will always act what direction? Always act along the along the surface in contact. Along the surface in contact. Is that clear? Now, how many type of friction force is there? Can you tell me? How many type of friction force we have? Please tell me. Please tell me how many type of friction forces we have?
Static friction and
Kinetic friction, right? We have two type of friction force. First one is what? Static friction. And the second one is what? Second one is called as the kinetic friction. Okay, what is the difference between these two forces? The simple difference between the static and kinetic friction is what? Whenever two surfaces are there in contact with each other and they are not sliding over each other, understand what they are doing? They are not trying to slide over each other. Understood? So in that case, what will happen? The static friction will be acting between them. Acha, sometimes we have a confusion about the static friction in such a way. They will give one object is moving with 5 meter per second and the lower object is also moving with 5 meter per second. Can you tell me what kind of friction will be acting between them? Static or kinetic?
kinetic.
Please tell me. Acha, now that's why I asked this question. Tell me, static or kinetic between them, between the bodies?
Static.
Static will be acting. Why? See, both the block are having the velocity, right? But what about the static friction nature? Meaning, the meaning of a static friction is what? That there should not be sliding between the bodies. So if both are moving with same velocity, are they sliding over each other? No. So that means what will be the friction acting between them? Here, the friction will be what? The static friction in nature. Just imagine here, these two palms are there, right? Both are moving, na? Check it. Both are moving together, na? Yes, there is a friction acting between them. But what kind of friction is that one? Static. But if I show you like this, can you tell me now? One palm is sliding over the other. So what kind of friction is there? Kinetic is there. So please keep in mind for static friction, they are moving or not moving, that is not important. What is important? Are they moving with respect to each other? Understood? Are they sliding over each other or not? If they are sliding over each other, apply the kinetic friction. If they are not sliding over each other, then apply the static friction. Is that clear? Please tell me. So, static friction is what? It is the friction, okay? It is the friction acting between the two surfaces, okay? Between the two surfaces in contact, okay, between the two surfaces in contact, if they are not sliding over each other, if they are not sliding over each other. Clear? Or another way you will see the same statement. Not sliding means what? No relative motion between them. Okay, if they are not sliding over each other, or you can say that having no relative motion between them. Both statements are same, just in different way it is written. No relative motion between these two surfaces. Okay, is that clear about the static friction? So that's why the role of a static friction is what? Role of a static friction is to keep the surfaces in contact at rest with respect to each other. Clear? Static friction will always try to do what? Keep the bodies in contact at rest. But can it forever keep it at rest? No. Understood? So the moment they will start sliding over each other, what kind of friction will be acting? Kinetic. Okay. So when the kinetic friction will be acting, tell me, it is the friction acting. Just some theoretical points are there. Why? Because if a theoretical based question will come, then definitely these small points you have to understand. Okay. So what is the kinetic friction when it will act? It is the friction acting between the surfaces, if if they are what? They are sliding over each other. Understood? Sliding over what? Each other. Then what kind of friction will be acting? The kinetic friction will be acting. So kinetic friction has a fixed value, but static friction is adjustable in nature. Adjustable means what? Static friction will only act. Static friction will only act how much? The requirement is there. Let's say I want only 10 Newton of static friction to keep the book at rest. So what will happen? Only 10 Newton of static friction will act. Okay. If I want 30 Newton of static friction to keep the block at rest, so only 30 Newton will act. So you will be thinking, sir, I need 100 Newton to keep it at rest. So how much static friction will be acting? 100 Newton? No, it's not like that. Static friction can adjust its value up to a certain limit. Okay, not forever. And that maximum limit of static friction is also called as limiting friction. So what is the limiting friction? Limiting friction is the maximum value of the static friction possible. Is that clear? Please tell me. Please tell up to what we have discussed about the friction force. Is this clear? There are two type of friction, static and kinetic. Static will try to keep the body relative to each other at rest. But if it is not possible for a static friction to keep it at rest, the friction will start, our friction will change its nature from static to kinetic. Clear? So what are the factors on which the friction force depend? So friction force depends on two factors. The one is normal reaction acting on the body, and the second factor is what? What is the roughness of the surface? How much rough a surface is? Okay, so let's say if a block is there kept here on the ground, okay, and some normal is acting on the block. Let's say you applied a force F here. If it is a smooth surface, what will happen? Can you tell me? If it is a smooth surface, what will happen? Please tell me. This block will start sliding, na? Please tell me. If it is a smooth surface, what will happen? The block will start sliding, isn't it? But in real life, whenever you apply a force, is the object start sliding that moment itself? No, isn't it? Think about it. You have the phone kept on the table. You apply a very small amount of force. Is it sliding? No, na? It's not sliding, na? But if you increase the force after some time, what will happen? It will start sliding, isn't it? Just think like this. To keep the pen here, I applied a very small amount of force. It did not slide. Understood? So what happened there? Initially, when I applied a small amount of force, the static friction was able to resist the motion, or you can say that able to stop the motion. But when I increased the force, what happened? The external force exceeded the maximum static friction. So that's why what happened, that moment onward, the block started sliding over the object or the surface. Is that clear? Same example, you see that when you apply force on a table, it slides, na? But you apply the same amount of force on the almirah, will it slide? No. Why not? Because different amount of static friction can act there. Okay, so friction we will have, okay, friction we will have what, the static friction value. Okay, so what is the static friction value? I applied force like this, so what the static friction will try to do, along the surface will be acting. Let's say it is Fs. Fs is for what? F static. So static friction or kinetic friction or any kind of friction force is dependent on the two factors. What are the two factors? Normal acting on the block and the roughness of the surface. It depends on what? The roughness of the surface also, you can say that. So friction force, if you want to write it, it will become how much? It will become equal to mu into normal. What is this mu called as? This mu is called as the coefficient of friction. Coefficient of friction decided by what? It is decided by how much rough a given surface is. Matlab, what is the roughness of a surface on which the other object is kept? Okay, so friction force will depend on two factors: coefficient of friction and the normal acting. So now tell me, what is going to be the static friction? So can I say here F static has what value? So F static value will be 0 to mu into n, and here I will use the coefficient of friction as mu s. Mu is the coefficient of friction and mu s is what? Coefficient of static friction. Understood? So what is the maximum value of a static friction? Can you tell me? What is the maximum value of a static friction? That is mu s into normal, and that can be also written as what? Limiting friction. Maximum value of static friction is also called as what? The limiting friction. Limiting friction, why? Because it is the maximum limit of a static friction. Static friction can adjust its value from 0 to mu sn, but not beyond that. Okay, so if it applied its maximum value and still the body is not able to stop, not able to stay at rest, then what will happen? Body will start sliding, and what kind of friction will be acting then? Then the friction will change its nature from static to kinetic. So what is the kinetic friction? Kinetic friction has the fixed value. Okay, kinetic friction value is what? It is always fixed. So what is the kinetic friction? Mu k into normal. What is the kinetic friction? Mu k into normal. So that's why you will see static friction sometimes written as self-adjustable. Self-adjustable in nature. Means depending on the requirement of static friction, depending on the requirement of friction to keep the bodies at rest, whatever the value will be required, that much static friction will be acting. So static friction is what? Adjustable in nature, but kinetic friction, it has the fixed value. Is that clear? Please tell me, clear up to this? Okay,
Sir,
so
can we
we have,
Yes.
yeah, tell me.
unity? I mean the one.
Can you tell me?
Can we tell that the maximum friction is one? Like it cannot be greater than one.
No. It's not like one or something. It can have value mu s into n. Depending on what is the value of static friction coefficient or coefficient of static friction and normal, the static friction can have any value from 0 to that value. And now I think your question is maximum value of mu s is how much? Coefficient of friction.
Yes, yes.
Yeah, coefficient of friction does not have any limit. Coefficient of friction can have any value. It is more than one also possible. Okay, mu s and mu k more than one also possible. But for normal surfaces, what happen? The value lies in the range of what? 0.3, 0.4, 0.5, 0.6, like that. But
Okay.
it is possible that this coefficient of friction can have any value. Very rough surface is there, we can have the coefficient of friction more than one also possible. Okay.
Okay, sir.
Now, before going to the question part, let's discuss two concepts. One is called angle of contact, sorry, angle of friction, and the next one is called the angle of repose. Okay, then we will discuss some example on that. What is angle of friction? Angle of friction means what? See, a surface is given to us. Okay, we applied a force here. What will happen? Friction will try to resist the motion, isn't it? Okay, let's say this is the mass of the block. So there will be a normal acting. There will be one mg will be acting. This is a rough surface on which we applied the force, isn't it? So when we applied this force, the friction will try to resist it, isn't it? So let's say friction is applied in this direction. I applied the force towards right. My external force is which direction? External force is towards right. So friction is acting in this direction. So what is going to be the maximum value of this static friction? Fs max is going to be, isn't it? Maximum value of a static friction is going to be how much? Fs max. So angle of friction means what? Angle of friction is angle made by resultant contact force. What is the angle of friction? Angle made by resultant contact force with normal is called the angle of friction. In the limiting case. In the what case? Limiting case. See, if I ask you what is the contact force acting on this block, can I say there are two contact force acting on this block? One is the normal, one is the static friction, isn't it? These are the two contact force acting on the block. Okay. So if these are the two contact force acting on the block, please tell me what will be resultant contact force? If I draw the same diagram here and leave about other forces, can I say this is one contact force and this is the another contact force? What is this Fs max? The Fs max will come as what? Mu s into normal, right? Now, if I calculate the resultant of these two, okay, if I calculate the resultant of these two, can I say the resultant will come something like this? And what is this resultant will be called as? This resultant will be called as total contact force. Okay, what is this resultant will be called as? Total contact force or just contact force. Okay, how much is that going to be? Is that going to be under root of n square plus mu s into n square? Please tell me. Total contact force or resultant force. Can I write it? It is going to be the n square plus fs max square, है ना? And fs max is also equal to mu into n. So normal square plus mu s into n square, isn't it? We can get the resultant and a normal into 1 plus mu s square. We got the total contact force. Now I want to know what is this angle, isn't it? What is this angle? Let's call it alpha. Please tell me how much is this angle alpha? If I want to calculate this angle alpha, tan alpha, how much it will come? Will it come this component divided by this component? Tell me. Tan alpha, if I want to calculate, are these two component is needed? So this component is mu s into normal and other component is just the normal. Simplify it and get cancel out. What is the tan alpha we have? Tan alpha is the mu s. And what is this angle alpha called as? This angle alpha is called as the angle of friction. Understood? What is this angle alpha called as? This is called as the angle of friction. So what is angle of friction? Angle of friction is angle made by total contact force or resultant contact force with the normal vector. With the normal vector, that angle is called as the angle of friction. Is that clear? Please tell me, what is the angle of friction? Angle of friction, if you want, you can write it. It is angle made by resultant or total. Okay, now resultant contact force with normal. In which case? In limiting case. In which case? In the limiting case. Understood? So when the limiting case is achieved, means I have applied enough force that this block is now cannot stay at rest. Now it has to move. So that is called the limiting case. So in the limiting case, what is the angle made by total contact force or resultant contact force with the normal? That angle is called as the angle of friction. Clear? Clear this one? So
Yes,
that
sir.
angle is called as the angle of friction. So how much the angle of friction? Tan alpha will come equal to coefficient of static friction. And one more angle is important here. That angle is called as the angle of repose. Okay, let's discuss that also. Angle of repose. What is the angle of repose? You have seen it that, let's say, an object is on a horizontal surface. I keep an object on a horizontal surface. Will it move? No, it won't move, isn't it? But let me increase the inclination. What happens? Did you observe what happens? After reaching a certain angle, isn't it the block starts sliding due to its own weight? So, angle of repose is what? It is that minimum angle of inclination at which the block will start sliding, or the maximum angle up to which the block will stay at rest on an inclined plane. Understood? Angle of repose is what? In terms of minimum you want to say, then you can say minimum angle है ना, at which the body will start sliding, or what else, the maximum angle up to which the body can stay. So let's say an angle theta is there. I'm trying to calculate the angle of repose. So tell me, when the angle of repose will be achieved, can you tell me what will happen with this block? So mg is acting on this block, isn't it? Normal is acting on the block. If I take the component of this mg, what are the components will come? This angle is theta, so this angle is also theta. So this component will come mg cos theta and this component will come mg sine theta. Right? Up tell me what will happen initially. Initially, mg sine theta is trying to slide the block down the plane. Right? This is a rough surface. This is a rough inclined plane. So initially what will happen when mg sine theta will try to slide it, friction will adjust its value, isn't it? Keep it at rest. I increase the inclination further. So that means I am increasing the theta, increasing the theta. So mg sine theta will keep on increasing, keep on increasing. So if mg sine theta will keep on increasing, that means what? After reaching a certain value, then what will happen? Friction will already applied its maximum possible value, isn't it? And that moment onward, even if I increase slightly the mg sine theta, the friction won't be able to keep it at rest. Understood? So, what will happen then? Then, at that moment onward, the body will start sliding. Understood? So, Fs. Can I say that for for angle of repose? Can I say that this Fs has reached its maximum value? Please tell me. So for angle of repose calculation, why it is helpful this angle of repose? You will see it in a question. For angle of repose, can I say that mg sine theta, when it will become Fs max, is it that maximum angle up to which it will stay at rest? And if I increase the angle even 0.001 degree beyond that, the body will start sliding. Understood? Because now friction is not have the capacity to keep it at rest because it's already applied its maximum possible value. So mg sine theta, what is going to be Fs max? Mu s into normal, can we write it? And look at these two components, normal and mg cos theta. In this diagram, is the normal is equal to mg cos theta? Is the normal is equal to mg cos theta here? So just let's put the value, है ना? तो mg sine theta equal to mu s into normal. Normal is mg cos theta, right? If you simplify, see that what is getting cancelled out? Mg got cancelled out. What is the tan theta we have? Is the tan theta is mu s? So see that mathematically, is the angle of friction and angle of repose is exactly same? Check the both expression. Tan alpha equal to mu s. Here alpha is the angle of friction. Here tan theta equal to mu s. What is the theta? Angle of repose. Clear? So what is the benefit of angle of repose? Angle of repose gives us a very clear idea that if I keep a block on an inclined plane, is the block is going to slide or not? Understood? The block will slide or not. Why? Because, see, let me give you an example. Let me take the value of mu as how much? Let me take in an example value of mu as, let's say there is a inclined surface whose mu s is 1 by root 3. Okay, I am just taking a very simple value so that our calculation will be easy. Tell me, mu s is given as 1 by root 3. Can you tell me, if I keep my inclination as 10 degree, will the block will slide or not? Please tell me. Mu s is 1 by root 3. That means, can I say that tan theta will come mu s? So that means tan theta equal to 1 by root 3. What does that mean? That means theta is 30 degree actually, isn't it?
Yes, sir.
So it, can I say that in this inclined plane, can I say that in this inclined plane, if theta is less than 30 degree, theta is less than 30 degree, is this block is going to slide?
No, sir.
Block will never slide. Understood? So like that, sometimes they will give you the mu s, then they will ask you a block is kept on that inclined plane. Tell me what is the acceleration of the block. Straight away, I can say that if theta is 20 degree, the block is not going to slide. Acceleration is zero. Next they gave theta is 45 degree. Will the block will slide now?
Yes, sir.
Same question, right? Same question, theta is given greater than 30 degree. Matlab, let's take it 45 degree. Can you tell me, is this block is going to slide over this inclined plane or not? The block will slide now. Understood? Block will slide now. So the moment block starts sliding, what will be the acceleration of the block then? Tell me, if the block is sliding on the inclined plane, what will be the acceleration of the block? So mg minus kinetic friction divided by mass. Understood? Please tell me, if the block is sliding on this inclined plane, then what will be the acceleration of the block? So here, can I say that in this question, if I want to calculate the acceleration of the block, what forces will be there? Normal will be there. Can I directly write the component? Mg cos theta. Other component, mg sin theta. And here block is sliding, na? So what kind of friction? Kinetic friction will be acting. So what will be acceleration of block in this case? Second case. First case, so it is not moving, hai na? Second case, can I say the acceleration of block will be mg sin theta minus kinetic friction divided by mass of the block? So mg sin theta minus, what is the kinetic friction? What is the kinetic friction? Mu s and mu k both are given same. Okay. So sometime mu s and mu k are given same. So you can just replace it by mu. Okay. The mu k into normal. What is the normal? Normal is mg cos theta divided by mass. Cancel out the mass from everywhere. So what is the acceleration of the block? We got it. G sin theta minus mu k into g cos theta. Or you can write it, you can take the g common, है ना? What do you have? Sin theta minus mu k cos theta you have. So that's why if a block is sliding on an inclined plane, what will be acceleration of the block in that case? So in that case, the acceleration of block is going to be g common sin theta minus mu cos theta. Sometimes the question give mu s and mu k separately. So then I have to use mu s and mu k as a separate value. But sometime you will see a question where mu s and mu k are not given separately. They will just simply state coefficient of friction is this much. What does it mean? It means they are telling you to take mu s and mu k as same. Why? The reason is what? Because mu s and mu k are different. Yes. But there is not a big difference between mu s and mu k. Very small difference will be there. Like mu s is 0.4, so mu k will be 0.38. Mu s is slightly greater than the mu k value. Okay, so that's why sometimes what happens in the question, they don't mention mu s mu k separately. In that question, you have to take both the value as what? As the same value in the problem solving question part. So please tell me what we discussed till now clear. Are you solving the question, all of you, or not? Practicing
Yes,
the
sir.
questions or not?
Yes, sir.
Please solve the questions, right? If you come up with the question, right, please ask it. Okay, get the answer. Okay, right, because the question practice part is very much important for your improvement. Okay, so please solve the questions whatever uh, you are getting, okay, from these topics. So next class what we will do, we'll discuss some more questions on the this friction calculation. Okay, friction force calculation, acceleration calculation. Okay, and then we will discuss about in detail about the gravitation force. Okay, please tell me, up to this part is clear what we discussed today?
Yes, sir.
Right, so let's meet it now on the Wednesday. Right now tomorrow is Tuesday, So let's meet it on the Wednesday now.
Okay, sir. Thank you.
Okay. Thank you so much. Right. But please keep on solving the questions. Okay.
Yes, sir.